Namaste children. Once again a small discussion on acceleration due to gravity. The acceleration produced in a body falling freely under the influence of gravitational pull of the earth is known as acceleration due to gravity, and it is designated by small g. It's different at different points on the earth because the dependent factors of g are the shape of the earth, altitude and depth. Considering the shape of the earth, it is not completely a sphere. It's flattened at the poles. So the value of g decreases as we go towards the center and becomes exactly at the center 0. And near the poles, the acceleration due to gravity is greater. And as we go to higher altitudes, the acceleration due to gravity decreases. And same way, as we go deep inside the surface of the earth, also acceleration due to gravity decreases. The value of g on the surface of the earth is 9.8 meters per second square. This is measured by using a device known as accelerometer. May not be necessarily the rate of change of velocity. Instead of accelerometer measures the acceleration associated with the phenomenon of weight experienced by any test mass at rest in a frame of reference. Accelerometer at rest on the surface of the earth will measure g is equals to 9.81 meter per second square, whereas in outer space it will measure g is equals to 0. The value of g is different on the surface of different heavenly bodies like sun, moon and the planets. Sign convention for vertical motion, the value of g is taken as minus 9.8 meters per second square or 10 meters per second square whether body goes up or falls down, because g always acts in downward direction, that is towards the earth. Distance measured upward from the point of projection is taken as positive, while distance measured downward from the point of projection is taken as negative. Velocity measured away from the surface of the earth, that is in upward direction, is taken as positive, while velocity measured towards the surface of the earth is taken as negative. So these are important points to solve the problems pertaining to a freely falling body. Always take u is equals to 0 if body is dropped from a certain height, and take v is equals to 0 at the highest point when a body is thrown upwards. Mass. Mass of a body is defined as the quantity of matter contained in the body. Since mass of a body is measure the inertia of the body, so mass is also known as inertial mass. The SI unit of mass is kilogram, and it is measured by using a beam balance or common balance. Some of the characteristics of mass of a body. Mass of a body is proportional to the quantity of matter contained in it. Mass of a body does not depend on the shape, size and state of the body. Mass of a body remains the same at all places. That means the mass of a body will be same throughout the universe. This is because the quantity of matter contained in a body does not change throughout the universe. So mass is a scalar quantity. Mass of a body does not change in the presence of other bodies near it. And masses of objects or bodies are added algebraically. Once again, the mass of a body is the quantity of matter contained in the object. Mass of a body is measure of inertia of the body, and hence it is called inertial mass. Mass is a scalar quantity. Its SI unit is kg and its CGS unit is gram. Mass of a body is constant and does not change from place to place or in the presence of any other body in vicinity. Mass is measured by a beam or common balance. Mass of a body cannot be or never be zero. What is weight? The force with which a body is attracted by the earth is known as the weight. Weight of a body is a vector quantity and it is measured by spring balance. The weight of a body on the earth is the force with which it is attracted towards the center of the earth. That is, the weight of a body is defined as when the mass of the body is under the influence of gravitational force, it is called its weight. Mathematically, weight is equals to the product of mass and acceleration due to gravity, or W is equals to mg. The SI unit of mass is Newton. 1 kg mass is 9.8 Newton. Weight is a vector quantity since it has both magnitude and direction. Change from place to place. Weight is measured by a spring balance. Weight of the body can be zero. When a body is taken to the center of the earth, acceleration due to gravity at the center of the earth is zero and hence weight is zero. On the moon, acceleration due to gravity is 1/6 that of the earth and hence the weight of the body on the moon is 1/6 of its weight on the earth. And the value of G is more at poles and less at the equator. Therefore, weight of the body is more at the poles and less at the equator. So, in other words, a body weighs more at poles and less at the equator. The value of G on the surface of different planets of the solar system is different. Therefore, the weight of the body is also different on the different planets. The value of G decreases with altitude and also decreases with the depth. The weight of a man is less on the peak of Mount Everest than the weight of the man at Delhi. So, weight is a dependent quantity which depends upon the mass of the body, the value of acceleration due to gravity at that place. Now the next term, the Now weight. What is weight? The force with which a body is attracted by the earth is known as the weight. Weight of a body is a vector quantity and it is measured by spring balance. The weight of a body on the earth is the force with which it is attracted towards the center of the earth. That is, the weight of a body is defined as when the mass of the body is under the influence of gravitational force, it is called its weight. Mathematically, weight is equals to the product of mass and acceleration due to gravity, or W is equals to mg. Weight of 1 kg mass is 9.8 Newton. Weight is a vector quantity since it has both magnitude and direction. Weight change from place to place. Weight is measured by a spring balance. Weight of the body can be zero. When a body is taken to the center of the earth, acceleration due to gravity at the center of the earth is zero and hence weight is zero. On the moon, acceleration due to gravity is 1/6 that of the earth and hence the weight of the body on the moon is 1/6 of its weight on the Earth. And the value of G is more at poles and less at the equator. Therefore, weight of the body is more at the poles and less at the equator. So, in other words, a body weighs more at poles and less at the equator. The value of G on the surface of different planets of the solar system is different. Therefore, the weight of the body is also different on the different planets. The value of G decreases with altitude and also decreases with the depth. The weight of a man is less on the peak of Mount Everest than the weight of the man at Delhi. So, weight is a dependent quantity which depends upon the mass of the body and the value of acceleration due to gravity at that place. Till now we discussed about universal law of gravitational force, Kepler's laws, that is Newton's inverse square law. What is the difference between small g and capital G? That is acceleration due to gravity and universal law of gravitational constant. Then we discussed about mass and weight of the objects and what are their differences. Now we are going to deal with the laws of flotation. What do you mean by thrust and pressure? Till now we have studied the deductions of Newton and Kepler. Now we are going to learn about Archimedes as well as Blaise Pascal. Now what is thrust? Thrust is nothing but it's force. So it's defined as the total force exerted by a body perpendicular to another surface. Any perpendicular force which is acting downward or in vertical position upward onto the surface of another body is known as normal force. This normal force is also known as thrust. And what is pressure? The thrust which is acting per unit area of the surface of another body is known as pressure. So mathematically, pressure is normal force by area or thrust by area, which is P is equals to T by A. When a blunt pin is applied force, it does not go into the wood, whereas a sharp pin goes into the wood with the same amount of force. Thus, the effect of force depends on the area of the object on which it acts. A sharp pin pierces our skin when pressed against it, but a matchbox does not pierce our skin when it is pressed with the same force. It is difficult to hold a school bag having thin straps as compared to a bag with broader straps. Similarly, if we push our thumb on a piece of wood, the thumb does not go into the wood, but if we push a drawing pin into the wood with the same force using our thumb, the drawing pin goes into the wood. It means that along with the magnitude, the force also depends upon the area of contact between the two bodies. In case of the drawing pin, the area of contact with the wood is much smaller than the area of contact of our thumb with the wood. Hence, the effect of force is larger. In case of drawing pin, the effect of forces of the same magnitude on different areas are different. Thus, the effect of force depends upon the area in contact with the body on which it acts. This gives a concept of pressure. So, pressure is defined as the perpendicular force or normal force or thrust acting per unit area of the surface. Thus, mathematically, pressure is equals to force by area or thrust by area or normal force by area. If P is pressure, F is the normal force or thrust, and A is the area of contact, then P is equals to. The body is also a force and it always acts in the downward direction. Observe the two different positions of the brick on the ground. Both the bricks exert same amount of force on the ground because they have same weight, but the two bricks exert different pressure due to the different area of contact with the ground. A lying brick exerts less pressure on the ground, whereas a standing brick exerts more pressure on the ground. Therefore, pressure depends upon force applied and area over which it acts. Pressure is the force acting perpendicularly on a unit area of the object. So, pressure is equals to force by area, or P is equals to F by A. Is a scalar quantity. Pressure is the force per unit area. Force is a vector quantity, but still pressure is a scalar quantity because it does not have any particular direction. Think that a point inside the liquid or a gas in a tank, pressure at the point acts in all directions, that is through 360 degrees. Therefore, pressure cannot be assigned a specific direction, hence it is a scalar quantity. At the same time, if pressure is applied on a surface, then the resulting force is a vector quantity since it has direction. The direction of effect of pressure on the surface is nothing but the direction of force. The pressure exerts force on the walls of a container of the liquid or a gas. SI unit of pressure is Newton per meter square or Newton meter square inverse or Pascal, and it is designated by capital P and small a. Pressure can also be defined in terms of thrust. Thrust is the force acting on a body perpendicular to its surface. So thrust per unit area is called as pressure. So pressure is equals to thrust by area. Some day-to-day applications, everyday observations on the basis of pressure are: school bags have wide straps, sharp knife cuts better than a blunt knife, tip of a needle is made sharp, pressure of the ground is more when a man is walking than when he is standing. Depression is much more when a man stands on the cushion than when he lies down or sits on it. The tractors have broad tires so that there is less pressure on the ground and the tires do not sink into comparatively soft ground in the fields. It is easier to walk on soft sand if we have flat shoes rather than shoes with sharp heels. Foundations of buildings and dams laid broad at the bottom to decrease the pressure.